Safety Integrity Level Determination Guidelines. Synopsis. This guideline outlines the methodology for conducting a safety integrity level determination study. It adheres to the intent of IEC 61511-3, which mandates the SIL rating of safety instrumented functions, SIFs. The guideline aids engineers, designers, and project decision-makers in delivering safe, reliable, and sustainable design outcomes. Contents. 1. Introduction. 2. Application 3. Roles and responsibilities. 4. Abbreviations and terminologies. 5. SIL Determination methodology. 6. Layer of protection analysis, LOPA method. 7. SIL verification. Introduction. Phase 2 of the safety lifecycle in IEC 61511-1 requires determining a safety integrity level for the design of a safety instrumented function, SIF. The main goal is to allocate safety functions to protection layers and determine the safety integrity level for each SIF. This ensures that the design is adequate and risks associated with SIF failure are tolerable. Allocation. The SIL determination process is applicable across all project phases. Define front-end engineering design, execute detailed engineering, and operate asset services maintenance upgrade. Roles and responsibilities. Project manager ensures the SIL determination requirements are executed as per the project execution plan, including appointing a SIL determination coordinator and facilitator. Determination coordinator project engineer organizes the SIL determination workshop and ensures the report is developed and circulated. SIL determination facilitator conducts the SIL determination workshop and develops the report, preferred for most workshops for efficient documentation. Abbreviations and terminologies. Safety integrity level, discrete value, 1 to 4, specifying safety integrity requirements, with L4 being the highest reliability. Independent protection layer, IPL, a safeguard preventing an unsafe scenario from progressing. Safety function, achieves or maintains a safe state for equipment concerning specific hazardous events. SIL determination methodology. Steps to determine a safety function SIL rating based on IEC 61511. 1. Perform a hazard and risk analysis. 2. Identify required safety functions. 3. Allocate safety functions to independent protection layers. 4. Determine if a SIF is needed. 5. Determine the required SIL of the SIF. Workshop preparation. Charter. Defines the scope, attendees, duration, location, and date. Timing. Conducted after the process design is finalized and as-up study is done. Attendees. Multidisciplinary team with process and equipment knowledge. Workshop duration depends on project complexity, typically 2 to 3 hours per SIF. Workshop procedure. 1. Introduce team members and their responsibilities. 2. State the objectives and scope of the study. 3. Outline the plan for the study. 4. Conduct SIF assessment. Establish context for each system. Identify required SIFs. Determine the required SIL of each SIF. Recording. Use computer software or MS Excel for consistency. Utilize a data projector for transparency and agreement among participants. Ensure documentation is understandable by those not present at the workshop. SIL Determination Report. The report includes scope of the SIL study, team involved, systems examined, assumptions and data sources, methodology used, results and meeting minutes, high layer of protection analysis, LOPA. Method. LOPA evaluates risk reduction through protective layers and determines the required risk reduction in terms of PFD of the SIF. Steps include 1. Select SIF identifier. 2. Develop impact event scenario. 3. Evaluate severity consequences. 4. Set target likelihoods. 5. Determine initiating causes and frequencies. 6. List independent protection layers and assign PFD values. 7. Calculate intermediate and mitigated event likelihoods. 8. Select the required integrity level for safety, environmental, and asset protection. SIL verification phase 4 of the safety lifecycle in IEC 61511-1 requires verifying that the design meets the required SIL rating. Verification ensures compliance with the safety integrity requirements. This guideline ensures a structured approach to determining and verifying the safety integrity level for safety instrumented functions, adhering to international standards, and promoting safe and reliable design practices. SIL Determination Workshop. Workshop procedure. The procedure for each meeting session includes 1. Introduction of team members and their responsibilities. An attendance sheet should be circulated to record all attendees' signatures. 2. Statement of the objectives and scope of the study, provided by the coordinator and/or facilitator. 3. Brief outline of the plan for the study, presented by the facilitator, detailing the study process. SIF Assessment 1. Establish context for each system. Explain the context and design intent of each system or protective loop. Identify the equipment being protected, the hazard and incident it is protected against, and existing independent levels of protection. 2. Identify SIFs needed. Determine required safety functions and the risk reduction they need to meet the safety target. Assess whether a safety instrumented function is required. If non-SIS protection cannot meet the safety target, a SIS-implemented SIF is required. 3. Determine required SIL of the SIF. Select the first SIF, hazardous scenario, to be examined. The facilitator explains the explicit purpose and intent of the SIF, including available safeguards. Assess and identify the SIL rating for each SIF. Recording the SIL determination process should be thoroughly recorded using a computer software for SIL determination or MS Excel to ensure consistency. A data projector is recommended for use during the workshop to allow all participants to view, recommend modifications, and agree on the minutes and actions. SIL Determination Report. To comply with standards, the SIL determination process needs to be documented. The report should include scope of the SIL study, the team involved, the systems examined, assumptions and data sources, methodology used, LOPA matrix, risk graph, results captured during the meeting. The report should be formally submitted for review and subsequently used as the basis for the SIL verification process. The document should include the full minutes, meeting attendance register with attendees' signatures, and any relevant attachments like drawings or data used as the basis for the study. Archiving. A hard copy of the SIL determination report must be retained according to the location's archiving procedure. Layer of protection analysis, LOPA method. The LOPA method evaluates risk reduction through protective layers and determines the required risk reduction in terms of probability of failure on demand, PFD, of the SIF. The method uses data developed in hazard and operability analyses and involves selecting a SIF identifier from the cause and effect tables, developing impact event scenarios based on hazard workshop records, evaluating severity consequences on health, safety, environment, and assets, setting target likelihoods after mitigation to meet tolerable risks, determining initiating causes and frequencies, listing independent protection layers and assigning PFD values, calculating intermediate and mitigated event likelihoods. The required integrity level for safety, environmental, and asset protection can then be determined. This process ensures the SIF meets the necessary reliability and safety standards. SIL Workshop Procedure. The procedure for each meeting session is as follows. 1. Introduction of team members and responsibilities. An attendance sheet should be circulated to formally record all attendees, including their signature to confirm attendance. 2. Statement of objectives and scope, presented by the coordinator and/or facilitator. 3. Brief outline of the plan, given by the facilitator, going into the study process in more detail if any team member is not familiar with the method. SIF Assessment. Establish context for each system and the safety target of the process. Based on the information prepared for each identified system, the context and design intent of each system or protective loop should be explained to the group. The responsible design person should provide this step as background to the group prior to assessment. Key issues to identify for each system or loop include the equipment being protected, what it is being protected against, the hazard and incident, what independent levels of protection exist. Identify SIFs needed. This step drives from the risk analysis what safety functions are required and what risk reduction they need to meet the safety target. It determines whether a safety instrumented function is required. Protection layers of other technologies should be considered prior to establishing the need for a safety instrumented function implemented in SIS. If no other non-SIS protection can meet the safety target level, A safety instrumented function implemented in SIS is required to protect against the identified hazards. Determine required SIL of the SIF. The required SIL rating of the identified SIF is determined in this step. Steps include: select the first SIF, hazardous scenario, to be examined. The facilitator asks to explain the explicit purpose and intent of the SIF, including any safeguards available. The facilitator assesses the first FF. The SIL rating of each SIF will be identified. Recording. The SIL determination process should be recorded thoroughly using a computer software for SIL determination or MS Excel to ensure consistency. It is highly recommended that a data projector is used during the workshop so all participants can view the record, recommend modifications, and agree on the minutes and actions, thereby minimizing any revisions and modifications required later on. The study team needs to agree on the similarity equivalence of multiple units in order to review only one unit. SIL Determination Report. To comply with the standards, the SIL determination process needs to be documented. The facilitator and/or scribe need to formally document the SIL determination process. This should provide and contain information on scope of the SIL study, the team involved, the systems examined, assumptions made, data sources used, methodology used, LOPA matrix risk graph, the results as captured in the meeting. The report should be formally submitted for review and subsequently used as the basis for the SIL verification process. A typical outline for a summary report includes standard report cover pages, report disclaimer, introduction and project overview, objectives and scope, team composition, recommendations and major outcomes, attachments, drawings, data used as the basis for the study, full minutes, meeting attendance register with attendees' signatures included. Archiving. A hard copy of the SIL determination report must be retained according to the location archiving procedure. LOPA methodology. Protection layers. The process identifies and classifies protection layers to ensure the identification of safety instrumented functions, SIFs, that are crucial for maintaining safety. These protection layers can include physical barriers, control systems, alarms, and procedures that contribute to risk reduction. LOPA steps. The layer of protection analysis, LOPA method, involves several critical steps. 1. Select SIF identifier. Choose a safety instrumented function identifier from the system's cause and effect tables. 2. Develop impact event scenario. Create an impact event scenario based on hazard workshop records, detailing potential consequences and initiating events. 3. Evaluate severity consequences. Assess the severity of potential consequences in terms of health, safety, environment, and asset impacts. This includes determining the exposure factor for environmental effects and consequences. 4. Set target likelihoods. Establish target event likelihoods after mitigation to meet tolerable risk criteria. 5. Determine initiating causes and frequencies. Identify all possible initiating causes and their frequencies, considering control system performance and intervention limits. 6. List independent protection layers. Enumerate the independent protection layers and assign probability of failure on demand, PFD, values to each layer. 7. Calculate intermediate event likelihoods. Multiply the initiating event likelihood by the PFDs of the protection and mitigation layers to determine intermediate event likelihoods. 8. Calculate mitigated event likelihoods. Further refine the event likelihoods by incorporating additional protective measures. 9. Select required integrity level. Based on the intermediate event likelihood, determine the required integrity level for safety, environmental, and asset protection. This may involve selecting a PFD for the SIF that meets the required maximum for the safety instrumented system. Example calculations. Required event likelihood. This is calculated by multiplying the intermediate event likelihood by factors such as the probability of ignition, occupancy, and fatality for safety scenarios, or exposure factors for environmental and asset impacts. Probability of failure on demand, PFD. The PFD of the SIF should be selected such that the resulting mitigated event likelihood meets the target criteria. Additional considerations. Demand rate. The number of times per year a hazardous event could occur in the absence of the SIF. This is determined by considering all potential sources of failure. Limited credit is allowed for control system performance and intervention unless the system is designed and maintained according to relevant standards. Calibration factor. A default value is used to ensure the risk graph results in a level of residual risk that is tolerable. This factor helps in recalibrating the risk graph if the demand rate is high. Implementation. SIF descriptor and reference. These are crucial for identifying and reviewing each SIF. The facilitator ensures all necessary elements are satisfactorily completed before the workshop. If required, the facilitator can postpone or cancel the workshop. By following these steps, the LOPA methodology provides a structured and comprehensive approach to evaluating and managing risks through independent protection layers and safety instrumented functions. This ensures that the required safety integrity levels are determined and maintained for the protection of people, the environment, and assets.